All right, so to expand it with Pascal's triangle and binomial theorem, here's what we're going to do. You're going to be given some expression, and what you're going to do is you're going to write out the number of rows from Pascal's triangle. That if we're doing x to the whatever we're doing to the seventh power, it's always the second number here because again the first number is always one. So if we're doing x expanding something to the seventh power, we're going to use something that's got row seven in the row up here. So we'll be using this one. If we're doing x to the fifth power, we would use this row because it's got a 5 in it. So whatever power we're working with, that's kind of where we're going to go. And it's always that second number that we're looking at for this thing. And then you're going to write down the first term of this expression, but you're going to start with it in descending order. And then you're going to take the second term of the expression and write it down in ascending order. And then once we do that, we're going to take each of those columns we've got now and multiply each column together to get each term in the answer that we're going to do for this thing. Okay, and then a couple notes at the end of it here. Again, anything raised to zero power is 1. And if it has a minus sign in the middle, then all we have to do is instead of all the terms being positive, we're just going to alternate from positive to negative to positive to negative to go through that route. Okay, so there's all the steps and everything, and I want to give you this so you didn't have to worry about writing all this stuff down because that would slow us down. So let me give you some examples, and we'll kind of go from there just so you can kind of see what it is. All right, I'm going to start you off one with it's pretty easy. Some people get confused because it's got 2 variables on it, but it's actually easier than everything else we're going to do. So for example 1, let's do this. Let's do x plus y to the 6th power. All right, so very first thing you're going to do is you're going to go back over here since it's to the 6th power. You're going to take the Pascal's triangle row that has a 6 in it, which would be this one right here for the second number. So we're going to do those numbers 1, 6, 15, 20, 15, 6, 1, and we're going to write those down. And when you write these numbers down, don't write them like really close together. Don't do this. You know, when you write down the numbers on this thing, space them out because that's where we're going to have room to show our work. So we're going to have 1, we're going to have 6, we're going to have 15, we're going to have 20, we're going to have 15, we're going to have 6, and you're going to have 1. Okay, and again, whatever your power is, it's here, that needs to match up with the second number of the row of Pascal's triangle that we're working with. Okay, take the first term, and you're going to write it down underneath these row of numbers, but you're going to start with x to this, whatever the first term is, to the 6th power, and then you count it down. It's x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. And if you want to on that one, you get x to the 0. You can kind of, because again, we said anything to the 0 power is 1. So if you want to go ahead and kind of scratch that out and just put a 1 there, then we know that that's going to be 1. And then for the second term, you're going to do the exact opposite. You're going to start with the 0 power and then work your way up. So it's the 0 power to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th, and then to the 6th. And somebody was saying, well, why don't we go ahead and simplify this one right here? We are. Go ahead. So that's 0 power. So go ahead and scratch that and just put a 1 there. Okay. And then all we're going to do is everything here, this is the answer to the first term. Everything in the second column is the second term, third term, fourth term, fifth term, sixth term. So you can think about each one of those as being one term for the answer what it's going to be. So now it's 1 times x to the 6th, which is just x to the 6th. We've got 6 times x to the 5th and y to the 1st. So it's 6 x to the 5th. And if it's y to the 1st, we can just leave it as y. We don't have to put the 1 there on there. And then the rest of the way, we're just going to multiply it out. So it's 15 x to the 4th y squared. It's 20 x to the 3rd y to the 3rd. 15x squared y to the fourth, 6xy to the fifth, and then finally at the end we've got 1 times 1 times y to the sixth, which is just y to the sixth. And that, my friends, is your answer. Now, think about if you had to do the full method with that over and over and over and over and over and over and over. How many arrows and how many terms and combining. And this takes care of combining like terms. This takes care of anything that's there. This is basically the shortcut to do the full method all those times over and over and over. Okay. Now, if you want to do the full method, you can, but you're going to drive yourself crazy because it's going to just go through and it's going to have stuff all over the place in this thing. And it's actually easier if you have two variables, because if you have two variables, you don't have to worry about multiplying anything out. It's actually going to be a little bit easier when it comes off of it. All right, now let's show you one where we've got a number, like we were doing earlier. Let's do x plus 2 to the fifth power. Okay, so that's x to the fifth. So we need the number over here that's got 5 in the second number. So we need 1, 5, 10, 10, 5, 1. So we got 1, 5, 10, 10, 5, 1. Okay, and then we're going to start with x to the fifth power and then count it down. So we got x to the fifth, x to the fourth, x to the third, x to the second, x to the first. And again, you can put x to the 0, but we know that anything to the 0 power is going to be 1. So we can just go ahead and kind of scratch that out and put a 1 there. Good. Now, here's where it's going to be a little bit more work from what we have to do. We're going to start with 2, and we're going to count up on the powers. It's 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and then 2 to the fifth. And yes, you just count them up. You start at 0, and then you count up. Okay. Now, when you have the numbers, here's what I would say to do. After you've got everything counted up and you've got all the stuff going on for these, if you've got a number on this one like we have here, I would say just before you do any multiplying on these, go ahead and tell me what these numbers are. It's 2 to the 0 power. That is 1, right? Because anything to 0 power is 1. What's 2 to the first power?
2.
That's 2. So scratch that out. Give me a 2. 2 squared is 4. And here's where the math gets easy. Get the next number, you just keep multiplying by 2, right? 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. There we go. We make the math easy that once you know what the base is, the first one's going to be 1, then you just keep multiplying by that base number until you count it up. All right, everybody good so far? All right, and then we're just going to do it one column at a time. What is 1 times 1 times x to the fifth? That's x to the fifth. All right, what is 5 times 2 times x to the fourth? 5 times 2 is 10. X to the fourth. All right, now we've got 10 times 4 times x to the third. Well, 10 times 4 is 40. X to the third. 10 times 8 is 80. X squared. 5 times 6 is 80. X to the first, or just x in that case. And at the end, it's 1 times 1 times 32, which is 32. And again, that big long thing is your answer that you're looking for. But again, that is about 1,000,000 times easier than having to do the full method all those different times for what you want to do. So basically, this is a shortcut. Instead of doing the full method a bajillion different times, It's just a shortcut to kind of, go around that a little bit. All right, now let me give you one with a negative in it. Just is that okay there? Is that so far so good? Okay. Yeah, just a little long. Now it's still long, but it's still a lot shorter than doing the full method over and over and over and over as we go through these. So, all right, so one with a negative number, and this will probably be one of the last things we get to. Let's do x minus 3 to the fourth power. Okay, so if we go to the row with the 4 in it, it's 1, 4, 6, 4, 1. Okay, and again, start with x and then count it down: x to the fourth, x to the third, x to the second, x to the first, x to the 0, but we know that's going to be 1. Okay, and with the don't worry about the negative. We'll worry about the negative then. Just worry about the numbers. It's 3 to the 0, 3 to the first, 3 to the second, 3 to the third, and then 3 to the fourth. All right, and before you start multiplying together, go ahead and take this last thing here that's got the numbers in it and tell me what that is. 3 to the 0 power is 1. 3 to the first is 3. 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 is 81. There you go. Okay. Now you can multiply them together. And you've got 1 times 1 times x to the fourth, which is pretty easy. That's just x to the fourth. We've got 4 times 3, which is 12, x to the third. 9 times 6, which is 54, x squared. 27 times 4, or 25 times 4 would be 100. So 27 times 4 should be what? 108 x. And then 1 times 1 times 81 is 81. Okay, now if this was plus, every single one of these numbers would be a plus all the way down. But because it's a minus in the middle, you're going to alternate. Start with a positive. Next one is a negative. Next one's a positive, negative, and then a positive. So if there's a minus in the middle, all you have to do is just alternate your answers starting with positive, and then just go positive, negative, positive, negative, positive, negative, or whatever proportion may be. Okay, and that is, yeah, and that's our shortcut. Instead of doing the binomial full method, 4, 5, 6, 7 times, now you just do this thing with Pascal's triangle, and it gives you the shortcut for the numbers that you're looking for. All right. And again, this takes like just a couple minutes to go through these. If it was the sum of cubes, and again, y'all have seen this, but a lot of people didn't get this on 2 tests ago. So we're going back and just reminding you of it here for this one. If it's the sum of cubes and they ask you to factor it, just remember that's where you're going to have something like maybe like x to the third plus 8. That you've got to break it down. So it's something cubed times something cubed. So if you have a number like 8, you got to rewrite 8 as 2 to the third power. If this was, what it was. Basically, here's what you're going to do. Whatever these 2 cube things are, you're going to rewrite those without the cube part. So if it's x cubed plus 2 cubed, it's just x plus 2. All right. Then it's the first term squared And then you're in the middle, you're going to multiply these two numbers together. So we're going to multiply 2 times x. But if it's a plus here in the beginning, then this one's going to be a minus. And then at the end, it's going to be the last thing squared. So whatever the two numbers are with the same sign here without the cubes, and then it's the first thing squared, these two things multiplied together, and then the last thing squared. And then with that last thing being a number, you can just go ahead and do 2 squared and make it 4. Okay, and it seems like you can do more to it than that, but that's all that you can do for those. And I think they always show, and again, we talked about it a little while back, but if it's going to be two things cubed, if it's a cubed and b cubed, it's always going to be a plus b. Whatever the a term is, you're going to square it. You're going to subtract the a and the b multiply together. You're going to add together the b squared term. Okay, and if it's the difference of cubes, it's almost entirely the exact same thing, but you're just going to flip flop your first two signs. So let's say it was y to the third minus 125. Okay, 125 would be 5 to the third. So again, you're going to take out whatever these numbers are and just rewrite it without the cube. So if it's y cubed minus 5 cubed, it's just y minus 5. And then you're going to take whatever this first term was, and now it's going to be y squared. And then multiply these two things together, so it's 5 times y or y times 5, which is 5y. And that's the last number squared. But again, we can do 5 squared and make it up to be 25. Okay. And I hate to say that this is one of those, when you're doing the sum and difference of cubes, it's just a memorization thing. But it's just a memorization thing. There's not really anything else you can do to it. You just have to realize that it's always, once you know what the cube things are, it's these two things without the cube part of it. And then it's the first term squared, these two things multiply together, and then the last term squared. And then that's it. It's just a memorization thing. So some people didn't get it on the last test we did. Well, actually, there's 2 tests to go. So just kind of going back and re-showing it to you here. It's not a big, huge deal. We just need to make sure that somewhere in the back of your mind it's kind of floating around there.